So we'll kind of see how we're doing with all the graphing lines when we get those quizzes back. All right, so for the opener, and this will just be a quick reminder of how to graph lines. This top line that is in slope-intercept form, they're both in slope-intercept form. So I'm going to put a dot where y is 6. 2, 3, 4, 5. Again, I'm not going to talk over anybody, so I will just wait and wait and wait. All right. Then for a slope of 1/3, it's positive, so I want it going up as I go to the right. 2, 3, then down 1, 2, 3. And even though I don't have extra points, we'll just extend that line to span the entire graph. The slope here is 1/3. The next line has a y-intercept of 2. This slope is -3. Okay, so that should be going down as I go to the right. So I'm going to go down 1, 2, 3, and right 1. Down 1, 2, 3, right 1. These small graphs make it a little tricky. 1, 2, 3, left 1. That's good enough. Okay, and we get the slope of -3. All right, so your line just looks something like that. And this, we already kind of know what this is getting at, our lines being perpendicular. We'll talk about kind of the definition of perpendicular lines, but if you know about perpendicular lines already, basically they form 90-degree angles with how they intersect. Okay, so you'll see that noted by that kind of half square there. We don't do anything with angles in this class. That's more of a geometry thing. But I'm sure that's something that you all probably did a little bit of work with back last year in 8th grade, or whatever math class you took last year. Okay, so I'm sure that's something you all have seen before. All right, let's skip the graphing part of this next one. Actually, you know what? Let's review it. This is our point slope form, and this is the one that a lot of us get mixed up. Okay, so again, I'm going to start with an x coordinate and a y coordinate. So x is 5, y is 9. So I'm going to go right 5, up 9. And slope of 4. Well, I can't go up 4 over 1. Okay, and Preston and Laszlo, if we're going to talk, you can just go out in the hallway and talk. Okay, again, I'm done with it. Going up 4 and right 1 will not put a point on this graph. So instead, I'm going to go down 1, 2, 3, 4, and left 1. Slope of this line is 4. And then the last line we need to graph has a starting point where x is -1, y is -2, so left 1, down 2. And the slope of -1/4 is telling me to go down 1 and right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. And once again, by these intersecting, we get that perpendicular line where they form 4 90-degree angles. And the main kind of takeaway for what we're focused on in this class is this relationship between the slopes. Okay, and yesterday we should have picked up that parallel lines all have the same slope, right? That's why they never intersect, because we keep doing the same rise over run when we have parallel lines. Okay, so perpendicular, there's a different relationship between the two slopes there, which brings in some new math vocab. So perpendicular lines intersect to form 4 90-degree angles. Again, we really don't do much with angles in this class. In geometry next year, you'll do a lot with that. And the equations of perpendicular lines will have opposite, and opposite meaning different signs. So one sign is positive, one sign is negative. Opposite and reciprocal. This is always a word that I don't know how to spell. Reciprocal. I don't think that's right. It's close enough, though. And reciprocal means to flip the fraction. Okay, so perpendicular lines have opposite reciprocal slopes. So if we look at the opener here, we had one slope that was positive, one slope that was negative, one slope that was 4, and if I put that over 1 and flip it, that's how we get that reciprocal of 1/4. Okay, same thing with the 1/3 and -3. So it's two things that have to happen to create these perpendicular lines. Switch the sign and flip the fraction. If it's not a fraction, we can put it over 1. Other than that, it's the same lesson as what we did yesterday. Okay, so we'll get more practice of writing equations. Most of what we focus on when we're writing our new equations are the original slope. So this asks, what would the slope of a line perpendicular to each given line be? I'm going to do A, have you all do B and C, and I'm going to call in a couple groups to help me out with that. Again, the only thing I care about here is the slope. I don't care about the -6. I don't care about anything else there. Okay, so the original slope is 3/4. The opposite reciprocal, well, opposite makes it negative. And if I flip 3/4, that turns it into 4/3. All right, you are all going to do B and C. And plan on for the rest of this lesson for me to kind of do what I did before or what I've done with. So you can check to make sure that you have the correct opposite reciprocal slopes. Again, in the equation provided, the only thing we care about is the slope itself. I don't care about anything else going on with that equation, just the slope. All right, next thing we're going to do is we're going to take, but then we need to make sure that it passes through the given points. So there's a little bit more that we have to do here. I'll do A, I'm going to have you all do B. So it says write an equation of a line that is perpendicular to the given equation and passes through the given point. So in the equation, the only thing I care about is the slope itself. And what I'm going to do is I'm going to take that slope and I'm going to figure out its opposite reciprocal. I'm going to make it a fraction by putting it over 1. So when I take the opposite, it becomes positive. And then flipping 3 over 1 makes it 1/3. So my new slope is 1/3. And it needs to pass through this point. So it's going to be y minus 3. And it equals 1/3 times x minus 1. The 3 coming from the y coordinate, the 1 coming from the x coordinate. All right, you all do part B. Should take you about 1 minute. And then just like before, I'm going to have y'all help me with Dean and Anna helping me out next. All right, so for everyone watching the video, you can check to make sure you took the opposite reciprocal, included the right slope there. And then on the back side, we've got the same kind of problem here. And you know what? Let's just make this go a little bit quicker because I want everyone's voice to be heard at least once. So let's just go right through this. So Gemma, what's the slope of equation A? All right, and for everyone watching the video, you can check to make sure that you have these equations right with our new perpendicular slopes. And now we're going to have to take the slope from a graph and do a little bit of finding slope. So let's do this one together real quick. So it says write the equation of a line perpendicular to the line that is graphed and goes through the indicated point. Write your answer in point slope form. So I'm going to find my rise over run. And make sure that when you do that, you're finding 2 points that intersect at whole numbers. Because now my rise over run, I'm having to go down 1, 2, 3, and right 2. So -3, 2. So the original rise over run is -3/2, which makes the perpendicular slope of that line 2/3. All right, so I think we got everybody from that group. So now let's go to the group right next to me here. All right, for everyone watching the video, we found the slope to be -3/2, which makes the perpendicular slope 2/3. Using the point -1, -8, we get the equation y plus 8 equals 2/3 x plus 1. Having everybody now work on problems 5 and 6. We're going to skip 7, so just go ahead and do 5 and 6. Basically doing the same thing I did here in 4. And then we'll pick up from there. All right. Ken, if I don't answer your question, I'll get to it in just a second, all right? Okay, so number 5, the slope of that line, is 2. What did I not do? So what kind of equation did I write up here? That equation is what relationship to the one that's graphed? Yeah, so you're telling me the form, but what is the relationship between this equation to the equation that's being graphed? Is it the same? Because this one has a y-intercept of 6, that one has a y-intercept of 2, so it's not the same. Okay, but the slope of here is the slope of... What did you all do yesterday? Yeah, right? The slope was 2. My new line had the same slope of 2. So I made the mistake of writing the parallel line that passes through that point. That's going to happen all the time. Okay, that's why, again, I need to slow down. We all need to slow down and say, okay, I found the slope, but I need to take the opposite reciprocal. And the opposite reciprocal of 2 over 1 is negative 1/2. Luckily, that's an easy thing that I can just fill in here without changing much. Make it negative 1/2. Now, I want to point out here that this point, 0, 6, is really the y-intercept, right? If you plot that point, that's on the y-axis. So you could write this equation in slope-intercept form as negative 1/2 x plus 6. All right, now I stopped on number 6 because this one gets a little bit weird, and it all kind of starts with what our slope is. Okay, so ideally, if we have studied, you would look at this line and say that slope is 0, right? I can walk across a horizontal line without any change in my slope. Now, maybe you don't remember that. That's probably most of us. We're not going to have that memorized and be able to recall it that quickly. Well, if my rise here is 0, right? I'm not going up or down at all. The run, based on these points, is 1, 2, 3. So that slope is 0. 0 divided by 3 is okay. When I flip that, when I go from 0 over 3 and take the opposite reciprocal, I get negative 3 over 0. Well, we cannot divide by 0. This is undefined. And so I'm like, okay, an undefined slope is one that is perfectly vertical. So a lot of students, they get here and they're like, I want to include the point. I'm not sure how to represent undefined slope. So what I would suggest is let's just graph the perpendicular slope and see if that helps. Well, I know that my perpendicular equation needs to pass through 2, 7. So I'm going to plot that point, 2, and then 1, 2, 3, 4, 5, 6, 7. Takes me off the graph a little bit. I know that perpendicular lines make 4 90-degree angles, and so this line has to be perfectly vertical and passes through that point. And maybe after you graph that line, you might go, oh wait, that's a vertical line where the x-coordinate doesn't change. The x-coordinate is always the same at x equals 2. So that equation is just x equals 2. There's no slope in that equation, or at least no slope that is being communicated. Again, the horizontal and vertical lines have properties that we need to memorize. So undefined slope passes through the x-coordinate of 2. Every point on that line will have an x-coordinate. That is 2. Okay, for you all to get a homework, you have 9 minutes to tell me whether A, B, and C are parallel, perpendicular, or neither. When you're done, bring it up to me. I'll give you homework if they're all right.